All right, so we are discussing section 3.5 on solving quadratic equations with the quadratic formula. So our target skill, solve quadratic equations with the quadratic formula and use the discriminant to determine the types of solutions a quadratic equation will have. So first thing is we are going to solve quadratic equations with the quadratic formula. So the quadratic formula. It's used to solve equations that are quadratic in standard form. So something like 3x squared minus 5x plus 6, for example, would work. That would be an example of a quadratic equation, and if we want to solve it, the quadratic equation must be in standard form, equal to 0. So this one would be in standard form, equal to 0. And then we can use the quadratic formula, and also once we get done we got to put our answer in simplest form. So let's take a look at this formula. It says x, so x is our variable and that's what we'd be solving for. It says x is equal to the opposite of whatever b is, so we can figure out our b, we just have to put the negative sign in front of it, plus or minus, so it's an either add or subtract, we just have to do both. The square root of, I take the b value, I square it, I subtract 4 times a times c, so there's a product, a multiplication I'll have to work out, and then divide that whole numerator that I've calculated by 2 times the a value. All right, and see how we read this quadratic formula. X is negative b plus or minus the square root of the quantity b squared minus 4ac, and I should probably add a word in here like all divided by, something like all divided by 2 times a. And finally we got a little definition here. The definition is b squared minus 4ac, so this quantity that's underneath the radical when we're using the formula, that is called the discriminant. The discriminant. More about that later. Alrighty. So let's go into our first example here. So we've got a quadratic equation. 2x squared plus 6x and it equals 4. So our first thing is, and I've got the steps here, get the equation equal to 0 and divide out any GCF from both sides. Well, if I get it equal to 0 first, in this case I'm going to have to subtract 4 from both sides. And then I'm going to check to see if there's a GCF, and I don't really have to check the right side. The right side is 0. I'm checking this left side to see if there's something I can divide everybody by to make the problem smaller and easier to calculate with. So in this case, everybody's divisible by 2. And I'm just going to do that then. I'll divide everybody on this side by 2, and I got to divide the right side by 2 as well. So my starting equation, actually, the one I'm going to solve, is this equation, which will have the exact same solutions as the initial one. Okay, so there I am. I'm in standard form and I equal 0, and I can't be any smaller than a 1 in front of that x squared. Alrighty, so now I'm going to figure out my a, b, and c. And a, b, and c, once you're in standard form, it's a piece of cake. Right, because a is what's out in front, just goes a, b, c ordered. B is what's in front of the linear term, the x, or the coefficient of the linear term. And then c is your constant, right there, the negative 2. Step 3, now we're going to calculate the discriminant. So we're going to plug in our b and our a and our c, and we're going to figure out what that discriminant is equal to. So discriminant equals, and let's go b squared, so my b is a 3, so 3 squared minus 4 times my a times my c. We just got to square this rather, multiply these, and then subtract them. So a few tips about calculating your discriminant. First thing is, whatever b is, you are squaring it. So even if this was a negative 3, when I square it, I always get a positive. So this will always be positive, you just have to square the number. The second thing is the multiplication here. Right there we have this multiplication. So I usually take, I sometimes take the negative and treat it like negative 4 times 1 times negative 2. And other times I just leave the negative and treat it like a positive 4 times 1 times negative 2. Well, what makes me decide? Well, I look to see if I've got two negatives here. Because if I have two negatives that I'm multiplying together, then it's going to be a positive as a result. And so in this case, I take the negative with it and go -4 times 1 is -4, and -4 times -2 is 8. Add 8. So it's a plus 8. And that just gives me a discriminant equal to a 17. But now that we've calculated it, and we'll use that number a little bit later on to help us figure out the types and number of solutions we have. But for right now, since we've done our discriminant work ahead of time, we can just slip that 17 right into the quadratic formula. So it goes negative a b, and so I've got to use this b value up here, which is 3, plus or minus the square root of the discriminant, but the discriminant is 17, all divided by 2 times a, and my a value is just 1. And so in the denominator there, I can actually take the 2 times 1 and just get 2. Now we're going to have to be simplifying these answers, and the way we simplify is just separate them. We'll practice this in a little bit. But this is just a fraction with the same denominators of 2, and so I can just separate the addition or subtraction problem by writing them in their separate fractions. And this is going to allow you to simplify this fraction or simplify this fraction if it's possible. Okay? For right now, like in this problem, these two answers, this or this, are equally correct. Okay, so it says simplify your answers. We really can't simplify our answers. So this one I'd probably leave in this form. Or we could use this form right there. Okay, so either one would work. Now we want to graph it so we can check out the relationship between the solutions to this equation we just solved. Actually, this equation we just solved where it was equal to 0. And our graph. So when I tried to solve this green equation here, I found out when the y values are 0. And so that's what our solutions are. And I've got my calculator here, if I can pull up my Desmos so you can take a look at it. And I've gone ahead and I graphed, before we divided out the 2, I just took this equation, 2y squared minus 6x minus 4, or this initial equation after we took the 4 to the other side. And I graphed it. I said, hey, set it, have y equals that equation. And then that allows me to just look at the y-intercepts to say, hey, here's where y is 0 when x is negative 3.56 or when x is 0.56. So how does that relate to my answers I got? Well, if you take a look, right there on my Desmos and right there on my Desmos, you can see I've typed in our two solutions. Negative 3 plus the root 17 over 2, and I get that decimal, that 5.655 that's in my Desmos graph. And likewise, when I do the negative 3 minus the root 17 divided by 2, I get the other 0. So these are the zeros of my function. So why don't we just use our graphing calculators to get these solutions? Well, these decimal values for our answers, 0.561 ... and negative 3.56 about 2 ... These things are approximate. These decimal values that my Desmos gives me are infinitely long. They never have a repeating pattern. They are irrational answers. And irrational answers are these decimals that just never repeat, and they never end, and they never have a pattern. And so the only way to really write down the whole value of that number, all the decimal places, is to leave it in this exact form. To say, hey, you know, as soon as I take the square root of a 17, I'm going to get a decimal that never ends. So I'm just going to leave it as a root 17, saying, hey, I want you to use it just like this. If you want a decimal value, you get to decide where to round it to. I'm not making that decision. How do we graph it now on our paper? Well, I am going to steal that vertex there real quick so I can draw a pretty decent graph. There's the vertex of this parabola we started with. And so he's going to graph pretty easy. I'm going to use the decimal values. Right? When I graph it, it's not going to be perfect. And so I'm allowed to use like 0.56 about right there, and negative 3.56, so negative 3.5 about there. So I know it's going to cross the x-axis about there and about there. We can even give the exact value or location of those things. This is at -3 plus the root 17, because that would give you a bigger number than this one, which would be a big negative, -3 minus the root 17 divided by 2. And then that little vertex I stole, -1.5, -8.5, that'd be about right there. So if you recall, our axis of symmetry sits right in there. This thing would go over 1 and up 1 and eventually hit those points. So, we could go over 1, up 1, and then over 1, up 3. 1, 2, 3. I think I've gone and counted too much. Oh, our A value is 2, sorry. Over 1, up 2. There we go. And then over 1, up 6. 1, 2, 3, 4, 5, 6. That puts me right there about. Remember, these are all approximates. And then I step over 1 and I'd have to go up 10 and I'd cross through that 0 that I have marked there. Right? You don't have to graph this accurate, but I had the time when I was doing this, so oops, this one would be somewhere around right over there. Because that thing would be actually at 0.5 on the right hand side, and this thing is like at 0.5 in the x, and this one, his x value is about 0.561. So he's just a little bit to the right of that 0.5 mark. Okay, so that's how we solve these things, not really graphing them, but using the quadratic formula. All right, last thing is on this page is real quick, I want to show you how this stuff all fits with what we've been doing. So, quadratic equations, there's 4 ways to solve these quadratics. Okay, first way is, so here's my example quadratic, and we could solve it by factoring. Right, x squared minus 16 equals 0, that's my difference of 2 squared numbers. So it's x minus 4x plus 4, and then I can get my solutions, 4 and -4. So that'd be way 1, I could solve a quadratic. Way 2, I can solve a quadratic, is notice there's no middle term, no b term, so if there's no b term, you can use the square root method. And this time when I take the -16 over, it becomes positive. I square root it, and I can square root the 16, so I get plus or minus 4. Again, the same 2 answers. And then our third way is I could just graph it. Here's the equation I'm trying to solve. So I make the 0 into a y, and I graph all the values of x and y. And then I look specifically where are the y values 0, and I can see it's at -4 and 4. Again, the same 2 answers I've been getting. And then finally, using the quadratic formula, my a value is 1, my b is 0, and my c is -16. So I didn't separate my discriminant, but there it is, b squared, 0 squared, minus 4 times a times c. And there's my negative of b in front of it, all divided by 2a. Oops, got an extra paren right there. 2 times 1. All right, so in here, I square it, and that's just 0. There's double negative, so I multiply that 64. It becomes 0 plus 64. So 64 inside, which is just an 8. 8 divided by 2 is plus or minus 4. Okay, so we're going to be working on this quadratic formula. The point is, we have 4 different ways, rather, to solve quadratics. Sometimes they don't factor, in which case we can maybe solve it with the square root method. And sometimes you can't use the square root method, so maybe we can solve it by graphing the darn thing and finding them. Or if graphing them doesn't work, and graphing never works if the square root method doesn't work. I shouldn't say that. Graphing doesn't work when your answers are irrational. So these are all nice rational answers. They don't have those radicals and those decimals that go on forever. So here we could just graph it and look at the x-intercepts and find our quad formula. So 4 different ways to solve our problems. And now finally at the very end here about the discriminant. So just a very common thing to do is determine your discriminant first, and then once you know the discriminant, you can actually determine what kind of solutions you're going to have, not exactly what they are, just what kind they'll be. So if your discriminant is a positive number, greater than 0, then you always get 2 real solutions because you're square rooting a positive number. If your discriminant comes out to be exactly 0, then you only get 1 solution because you get negative b plus or minus 0 on top. And so negative b plus 0, negative b minus 0 give you the same number, negative b over 2a. So you just get the one answer. You'll just touch your x-axis twice. So real solutions will do this. Cross the x-axis in 2 positions. If your discriminant comes out to be 0, it only touches your graph in 1 spot, like that. And finally, if your discriminant is less than 0, you're square rooting some sort of negative number inside your radical. If that's the case, you'll always get imaginary solutions, and there'll be 2 of them. But your graph then wouldn't even cross the x-axis. So when you have a graph that doesn't cross, you get these imaginary answers. Alrighty, so that takes us on to page 2 here. And on page 2, we just start by simplifying a few of our radicals answers. So this is typically what answers look like when you get done with the quadratic formula. Like this is your negative of your b value, plus or minus. That's your discriminant that I already calculated. Divided by 2a came out to 6. Okay, so we're just going to simplify it. And so I showed you a little bit how to do this. You just separate them, keeping that denominator. Simplify them individually. So 4 and 6, they're both divisible by 2's. So we can do that, and that gives us 2/3. And then this radical, this is when you can simplify this guy. So square root of 8, you can just run off to the side if you need to. It's 4 times 2, so I can square root the 4. So it's a 2 root 2. Remember, that was when I said memorize that guy. There we go. And then I do, after I pull that 2 out, I want to check again. Can I simplify? And 2 over 6 simplifies to 1/3. They're both divisible by 2. So my final answer, 2/3 plus, I usually don't write 1/3. I just put root 2 over 3. It is like having a 1 sitting out in front of it. So there's our simplified answer. You could stop and pause the video if you want to try the next 2. Here's my number 5. I'm going to separate them. 5 over 2. That won't simplify. I could make it a decimal like 2.5 if I wanted to, but no need. So I've separated them into their own fractions. I see that I have a negative that I'm square rooting, so that gives me an imaginary number. So I break out the I. And now I have to run off to the side here and figure out what the square root of 24 simplifies to. Well, that's 4 times 6, and I can square root the 4. So that's our simple representation. So the 2's out there now, and so there's already an I out there. So 2I root 6 over 2, and hopefully you see it there. Those 2's are going to give you a 1. So it's 5/2 plus or minus I root 6. There's the real part. And there is the imaginary, the part that the I is multiplied by. Okay, but this is our full answer of how it simplifies. And then our last one here, oh, real simple one. 4 over 2 plus or minus root 17 over 2. That's a 2. Plus or minus root 17 over 2, or maybe like 1/2 of a root 17, just so you can see a different type of answer. Okay, but same thing as writing this would be the point. Just like that means the same thing. Alrighty, so let's solve a few of these quadratics, and then you can try the homework on your own. So here we go. Step number 1, I check to make sure it's equal to 0. It is. Meant to point at that thing. It is quadratic, and it's in standard form, the squared term, the linear term, the constant. So I'm going to grab my A, grab my B, and grab the C. I'm going to calculate that discriminant, b squared minus 4ac. I wonder if I'll get real answers, or if I'm going to get imaginary answers. A is 1, C is negative 5. And so again, you could just grab your calculator, and let me show you how I would do that on my calc. So for those of you who are going to choose this method, let me just start a new graph. And so I would type parentheses, negative 2 parentheses squared minus 4 times A times C. Notice I just used parentheses instead of having to use multiply. So it says 24. All right, let me show you the math way to do it by hand. So that's a 4. These have double negatives, so it's going to be an addition. 4 times 5 is 20, so I just go plus 20, which is 24. Same thing that I've gotten here over on my Desmos. Alrighty. And then real quick though, this discriminant, that's a big number. That thing is greater than 0. It's positive. So I'm going to get 2 real answers for this thing. Alright, let's go ahead and find those 2 real answers. So it's negative b plus or minus the square root of my discriminant all over 2 times a. So negative of the b value. What's my b up here? Negative 2. Oh, get myself some double negatives there. Square root of my discriminant, which is 24, all over 2 times a. So let's speed up our simplifying here. That's 2 plus or minus. Alright, 24 is a 4 times 6, so I'm square rooting the 4, leaving the 6. And I'm going to separate them, but I can see what's going to happen. 2 over 2 is going to give me a 1, and 2 root 6 over 2. And so I just get a 1 plus or minus a root 6. And there we go. There's my 2 answers that make this equation up here true. Okay. You can fast forward if you want to through this next little thing here, but I am going to prove real quick that these 2 answers do indeed work. I'm going to erase all my stuff. I'm just going to grab those 2 answers down there at the bottom, and I'm going to test them. I'm going to show you. I'm going to prove it. 1 plus root 6. There's my first answer. I'm going to square it. Minus 2 times 1 plus root 6 minus 5 has to give me a 0. Let's find out if it does. So I've got to square a 1 plus root 6. Oh my goodness, that looks hard. But we've done this before. Double distribution. 1 times 1. 1 times root 6. 1 times root 6. Root 6 times root 6, root 36. Alright, my next one, negative 2 times 1. And negative 2 times root 6. Well, that didn't simplify at all, so we'll just write that down here. And then, oh, minus 5. Minus 5. So let's start collecting like terms here. I'm going to zoom in here a little bit. See if we can find some like terms. I'm going to start with this 1 here. Oh, hold it here. Root 36, that's just a 6. So that's a 1 plus a 6. That's 7. And then I got to take away 2 and take away 5. Oh. So that's 7 minus 2, that's minus 2 minus 5, that's minus 7. These all cancel out. Boom, gone. That's gone. This is gone, and that is gone. Let's see what we got left here. I got 1 root 6 plus 1 root 6, that's 2 root 6's. Oh, over here I got to take away 2 root 6's. Yep, I get 0. Hey, it checks. If I plug in 1 plus root 6, that whole equation ends up equaling a 0. The same thing happens with 1 minus root 6. So we are finding the answers, right? Let's go ahead and solve this one. Step 1, get it equal to 0. So I'm just going to add the 6.25 to both sides, and that just makes it 0 on the right. Okay, and then I'm going to use, get my discriminant here. Let's write down what A, B, and C are. So A is 1, B is negative 5, C is 6.25. I'm going to calculate my discriminant now. So there's our formula. I'll always give that to you so you don't have to memorize it. You just got to know how to use it. And then I could get my calculator out if I needed to. I'm going to go show you how I do this one. So in this case, I see a single negative, and everybody else is positive. So when I multiply these 3 things together, the answer is going to be still minus. So I just go minus, and I figure out what 4 times 6.25 is. And in this case, that comes out to 25. And so I get 25 minus 25 is 0. So this thing's only going to cross the x-axis in exactly one spot. All right. Let's go ahead and I'll graph this thing real quick for you so you can see it. Here's the y equals x squared minus 5x and plus 6.25 when it was equal to 0. And I can see I've got a mistake. I dropped my 5. There it is. And so there's the graph. And I can see where it's going to cross. It crosses right there at 2.5. Let's have the rest of the quadratic formula show us that answer. So there's my formula. And I'm just going to go negative of my b value, which is a -5, right? Double negatives. Plus or minus the square root of a 0 over 2 times a, and a is 1. That's a 5. Two negatives make a positive. Plus or minus the square root of 0, that's just still a 5 up there, no matter if you subtract it or add the 0 to it. So I just get 5 over 2. 2.5. Exactly what my graph showed me. So in this case, graphing it would have solved it for you, and you wouldn't have had to use the quadratic formula. And then our last one here, I'm going to get rid of that guy. There we are. Let's see here. Quadratic not equal to 0. So let's get rid of these things, right? Just subtract the 2x. Subtract the 2x from its like term. Then we will subtract the 9 from its like term. So I've got 9x squared plus 8x's plus 7 equals 0. Check to see if I can divide by anything. Nope, cannot. So I'm going to go right into a is 9, b is 8, and c is 7. And b squared minus 4ac, the discriminant, is 8 squared minus 4 times a times c. Oh boy, we're getting some big numbers here. Minus, I'm going to get out a calculator for this guy. Was hoping to avoid that, but we'll put him up over on that side. Alright, so 4 times 9 times 7. I didn't even deal with the sign because I knew it was going to be a subtraction. Minus 252. And 252, or 64, minus 252, negative 188. I'm going to get two imaginary solutions. I'm going to be square rooting a negative sign. So x equals, here comes the quadratic formula. Negative b plus or minus square root of discriminant all over 2a. So negative of an 8 plus or minus root negative 188 all over 2 times a. Alright, and then we'll just finish up. Negative 8 plus or minus. I'm square rooting a negative, so I'm going to put an I out there. And now I'm ready to separate and simplify. So here I go. Negative 8 over 18 plus or minus I root. Now I got to factor this 188. And that's not an easy thing to do, right? But I'm looking for things that are perfect squares. And so I'm going to divide them by 4. 4 goes into it 47 times. And 47 does not break down any more than that. So I'm going to think of that as a 4 because I can square root that 4. And my final answer, both divisible by 2, plus or minus. I bring the 2 out to join the I, all over 18. So it looks like I got one more simplifying I can do. Let's see here. Gotta make sure. There we go. So I got negative 4/9 plus or minus I root 47 over 9. There's my final answer. Sorry, I ran out of room or went a little bit long on that one. Alrighty, jump right into this. How many solutions does each one have and type of them? All I'm going to do is calculate my discriminant. Now before I calculate it, I'm going to see if I can simplify. I'm going to make sure he equals 0. He does. So I'm just going to calculate this real quick. It'd be a negative 3 squared minus 4 times a times c, which is 9. And this comes out to, I think, 120. 30 times 4, yeah. So that's negative 111. And so that's negative. So, you know, you can figure this out yourself, but it'd be negative b plus or minus the square root of a negative 111, and that's going to give you imaginary numbers. So we say it has two imaginary solutions. That's all we do when we are asked to describe it. We don't have to find them. Next one, b squared minus 4ac. It already equals 0, so it's negative 10 squared minus 4ac. I'm going to be squaring a negative 10. But that's just a positive 100. And 4 times 25, and it's going to have one minus sign, so it comes out to 0. And the rule is that would be negative b plus or minus the square root of 0, so you just get one answer, divided by 2a, of course. So we say one real solution. And then our last one, not equal to 0, so let's get it equal to 0, because that's now when we can apply the quadratic formula. Even just the discriminant part, it has to be equal to 0 first. And so that's 9 plus, because I got double negatives, 36. So that's a, 45. That's going to give me two real solutions. And my last problem here, this is one you should try on your own, so I'll just run through it real quick. I don't like this fraction or that negative out front, so I'm going to take this whole side and multiply it by negative 2. And that means I got to do the other side. But negative 2 times a half is 1, and negative times negative is positive, and I got to distribute it, so negative 4x and positive 10. Negative 2 times negative 5. And now I can use the discriminant, figure out what kind of answers I'm going to have. 4 times a times c. Negative 4 squared, so that's a 16. So I get 16 minus 40, or negative 24. So I'm going to get two imaginary solutions for this guy. So x equals negative b plus or minus the square root of our discriminant. I'm just writing the formula down again for you. So negative of negative 4 plus or minus the square root of negative 24 over 2 times a. And my a here, remember I'm using that equation, is a 1. Alrighty, so let's see what that simplifies to. 4 plus or minus, I poke out the I. 24 is 4 times 6. I'm already starting to simplify it. I separate them. That's 4 over 2. The other one, the 2 comes out on top, and it'll be over 2. So 2 plus or minus I root 6. There's my answers, they're imaginary. And I'm supposed to graph this thing, so let's see. I can't graph an imaginary number, so what's this graph going to look like? So it is, and we'll graph the original function here, negative 1 divided by 2, x squared plus 2x minus 5. Look at that. That thing doesn't even cross the x-axis, right? It's got a vertex of 2, negative 3 right there. There's its axis of symmetry. It's kind of a wide parabola, but the point is, everybody, it does not cross the x-axis, and that's why we have these imaginary solutions. Alrighty, and it wouldn't matter. We could graph this other one as well. The cleaner problem, x squared minus 4x plus 10. All right, it's going to graph differently, but they will have the same values that give you your zeros, even though they are imaginary. All right, so they have similar, or they have exactly the same solution sets. Alrighty, that's it, and you should be good to go on the assignment.